My name is Drew Haney. I'm a tech lead on the mobile infrastructure team at LinkedIn. And I'm going to talk to you guys today about some of the stuff we've been working on to improve our mobile release process and speed up how quickly we can iterate getting new features out to our members. As most of you have probably seen, if you use the LinkedIn app on iOS or Android, we recently, back in November, at the end of November, released a complete rewrite of the application that we called internally Project Voyager. We started from scratch. We took a brand new code base and spent about a year of development time working on this rewrite. We took this as a chance not only to rethink the product from a user-facing product side, but we also wanted to improve on the way that we do mobile at LinkedIn and take this as an opportunity to invest in our mobile infrastructure. I took a look through the Git history as I was preparing for this talk and saw that we had over 250 unique committers between Android and iOS, which, as you can probably imagine, brings its own set of challenges, especially when you're looking at how to deal with that volume of commits and code coming in from different people. So before the Voyager project, we did monthly releases. So every month there was a particular date that we would pick a release candidate build, hand it off to the QA team, and they would go through a 4 to 5 day manual regression suite. And as you can probably imagine, if you're an engineer developing a feature for the app, as that release candidate cutoff date comes up, you will rush to get your code checked in and make sure that you make the release, because if you don't, you have to wait an entire month before the next release comes around. This led to a lot of cutting corners, particularly as we got close to the release, and if it became a question of, do I write that extra test or refactor this code, or do I make it into the release? You made it into the release. We didn't like this mindset. We wanted to enable our developers to focus on craftsmanship and code quality rather than worry about how quickly they can get their features out the door. From the product and marketing side, they also had to plan their schedules around this monthly release cycle, which put a lot of limitations on them. They weren't able to do as many experiments and real user testing to see what designs and product features would work best, because they only had 12 chances in a year to get code out. So it became pretty hard to iterate on member feedback as well. We had to try and get things right the first time. We wanted to change all this, so one thing we could have done is just made our releases more frequent. We could have said, let's release once a week instead of once a month or every 2 weeks. This really wouldn't have changed anything, we didn't think, because then instead of a once a month mad dash to get code in, we just have that happen once a week. And the QA team would be spending every week doing their regression suite rather than 1 week a month. We wanted a way to change the mindset of our company and of our engineering organization. So the rule we came up with, we called 3x3, which means we release 3 times per day with no more than 3 hours from the time that code is checked in to the time that that code becomes available to members. Now you're probably thinking, this is not realistic. You cannot ship an app to the App Store and Google Play every 3 hours. On the Apple side, Apple's review process right off the bat makes this impossible. On the Android side, we could technically upload to Google Play every 3 hours, but members would not really be happy with such frequent downloads, and we want to be respectful of their bandwidth and data consumption. But we did have a group of people that we could give new builds to every 3 hours, our employees. So why did we pick 3 hours? One of the main reasons was that this was not enough time for any manual testing steps. So we could employ someone who did testing every 3 hours, but we probably would not keep that role filled for very long. The other big point is it's not enough time to test everything, which may seem counterintuitive, but we didn't want 100% automation. We wanted to be able to iterate more quickly. We didn't want engineers to spend 20% of their time writing new code and the rest of their time fixing all the tests that break every time they touch something. We wanted this faster iteration to give us the high quality craftsmanship and let developers make that choice to add the extra test or refactor the implementation before checking in their code, because they knew if they missed this release, the next release was only 3 hours away. So what does our pipeline look like? This is a super high level overview, and the highlighted section here is the part that falls under our 3x3 3-hour time window. So I'll go through a high-level overview of each of these topics and what some of those things we've done to optimize them. And yeah, so for static analysis, this is probably one of the most important and easy wins in having confidence in our releases. So with our API server and our Android and iOS clients use Restly to talk to each other, which is an open source REST framework from LinkedIn. With Restly, we have a model data templates that are shared between all three pieces, Android, iOS, and API, and we have a code generator that creates the model classes for Android and iOS to use so that developers aren't handwriting these models, which is error-prone and tedious. On the API side, every time a check-in happens, we have a set of backwards compatibility checks that will guarantee that the API changes won't break clients that are in production without the API developer explicitly overriding those checks and saying, it's okay, we've deprecated these old versions of the client and we're safe to make this change. On the Android side, we use Java check style to make sure that code is consistently formatted across developers. And we also take advantage of the Android lint system, which comes with over 200 checks out of the box, and many of which we've set to error so that developers can't check in code that has these issues. And we've written several custom checks for LinkedIn-specific patterns. On the iOS side, we've been experimenting with the SwiftLint open source project and added our own custom checks there as well for LinkedIn best practices. So, building the code is one of the slowest parts that we have in our 3x3 pipeline, and one of the areas that we needed to get a little creative to make it fit inside our 3-hour time window. Between the Android and iOS code base, we have over 500,000 lines of code, which, as you might imagine, takes quite a while to build. On iOS, since we were rewriting this app from the ground up, we wanted to take advantage of Swift right away. We didn't know when the next time that we would rewrite our app from scratch would be, and we didn't want to be stuck with Objective-C for several more years. This was nice in a lot of ways, but also led to us going through quite a bit of growing pains with Swift. Early on, the Swift compiler was extremely slow and very picky about how you formatted your code, and different minor tweaks that you made could drastically increase or decrease your compile time. Early on, Swift compilation for our release builds was taking over 2 hours, which didn't leave us much time for the rest of the 3x3 pipeline. So with some work with the Apple developer community and opening a bunch of radars, we were able to find ways to refactor our code that got us more than a 50% speed up. I think we got release compile times down to 35 minutes, which is still pretty long, but relatively good. On the Android side, builds are pretty fast, but we wanted to take advantage of the Android build system split APK feature, which lets us create a separate binary for each combination of screen density and CPU architecture, so that members would only be downloading exactly the code that they need to run on their device, and not anything extra. This led to us generating, I think, over 30 different binaries, 30 different APK files for our Android build. Plus, we had our internal beta build, which was another 30 APKs if we wanted to generate split APKs there as well. So this was taking quite a while on the Android side. So we worked with our continuous integration tools team and came up with a way to allow distributed builds. So as a continuous integration job kicked off, it could send off child jobs to other machines that would build the release binaries while we ran our tests on the main machine. This let us cut down our time to whatever the maximum of the jobs was. So speaking of testing, should give a quick overview of the way that we organize our tests. So We have unit tests, which is exactly what you would expect from any software project. We also worked on what we call layout tests, which we consider to be like unit tests for views. So we take our views for the iOS and Android side, and we lay them out in a dummy screen with no other content, and we don't load the rest of our backend. There's no server models, there's no real data, not even really any mock data. We populate each view with different combinations of dummy strings with different lengths and different properties. Make sure that strings don't get cut off and views don't overlap and buttons don't go to 2 lines, and make sure that everything renders properly in right to left mode, which has been very useful. The closest thing we have to an end-to-end test is what we call scenario tests, or integration tests, you could think of them. These, I wrote here, these validate key business metric flows, which in English just means the most common things that the user does in the app. We want to make sure those are covered in our tests. So commenting on a feed update, liking a feed update, sending a message, editing your profile, or sending a connection request. Usually these are things that span multiple screens within the app, so they're not easily unit testable. And to make sure they're stable, the test author can provide mock data that is sent through a local fixture server running on the device to provide the data for the test. It's important to note this is not an exhaustive suite because we don't want it to take all night to run, but we do cover the most important flows to our members. One of the big things we ran into as trying to do these UI tests was just general test flakiness. On the Android side, we were using the Espresso framework from Google. On the iOS side, we were using Square's open source KIF library. And we found there were 2 general categories, speaking very broadly, 2 general categories of test flakiness. One was either something was not consistent in the testing environment, or there was some race condition in either the production code or test code that would cause tests to pass inconsistently or fail inconsistently. On the Android side, we found that developers were using a wide variety of different devices. Some were running tests on their personal phone, their 4-inch phone, 5-inch phone, 6-inch phone. Some were using the stock Android emulator. Some were using Genymotion. And we would run into all kinds of situations where tests would pass on one developer's machine but fail on another's or fail on the build server. So we wanted a way to make sure everybody was using the same setup. So what we did was we created a standalone self-contained Android emulator bundle along with a script for how to start that emulator. So then each developer could use the exact same configuration that the build server was using, and we wouldn't run into issues with tests that way. We also found on the Android side that the default way Android runs tests is it will start your application, run all your tests, and then stop your application, which led to any global state in the app. If that didn't get cleared between tests, it could lead to flakiness or tests that only passed if they were run after a particular other test. We ended up developing a custom test harness that will launch the application, run a single test, and then kill the app and clear all state before running the next test. If that sounds slow, you're right. We'll come back to that. On the iOS side, when working with KIF, we found a lot of situations where tests would pass on the developers' MacBook Pros locally, and then when we ran them on the build machines, which were some lower powered 2012 Mac Minis, they would fail, but fail inconsistently. So we took a deep dive into the KIF code and found a lot of hard-coded waits that KIF was expecting certain actions to take a certain amount of time. The dev machines were fast enough that these would always pass, but the build servers were sometimes slow or overloaded in a way that it didn't quite finish the action as KIF was expecting. We ended up creating our own custom version of KIF that removed all of these hard-coded waits and changed to a checkpoint-based system where the app code and the test code would notify with checkpoints of exactly when it was safe for the test to proceed to the next step. This fixed a lot of our stability problems on the iOS side. Now I mentioned the other category was race conditions in either the production code or test code. This is much harder to address systematically, but we have done some things to try and improve there. So every night we will take the last known good build and run the tests thousands of times. Basically as much capacity as our CI pool has, we will continue running those tests over and over. If any tests fail, we will turn them off and send a report to the developer saying, your test failed, here was the case where it failed, and they can investigate and hopefully track down the race condition or add more logging so that they can figure it out. Now, once we got things fairly stable, we had to focus on test speed to make sure we were within our 3-hour window. On the Android side, since we were using Espresso, we had the built-in idling resource API, which lets us avoid any sleeps and waits by knowing exactly when it's safe to proceed to the next test step. We were still finding, though, since we wanted to run our tests on a variety of OS versions and device types, that we needed to speed things up. Since we'd already written a custom test harness, and we already had a self-contained way of starting emulators consistently, the next step was to expand that script into letting us start multiple emulators on the same machine. So our CI boxes for Android are some pretty beefy Linux machines and that are actually capable of running up to 16 Android emulators in parallel on a single machine. So combining that capability with our custom test harness lets us run all of these tests in parallel to get the optimal speed on a single machine. On the iOS side, that KIF refactoring I mentioned, not only did it improve our stability by fixing the cases where KIF was not waiting long enough, it also improved our speed by fixing the cases where KIF was waiting too long. There was a lot of actions that finished much faster than the timeout, but KIF would wait until the timeout finished. So the checkpoint-based system cut our UI testing time by more than 80%, which was a huge win on the iOS side where things were already quite a bit slower. It still wasn't quite enough to meet our 3-hour window, though. So similar to distributed builds, we enabled distributed testing for iOS, where we can shard our tests across multiple Mac Minis to make sure that everything was running quickly. This was way faster, but it also led us to bigger exposure to any instability in the tooling itself. So if any box failed for some reason, the entire job would fail. And when you are running on 6 or 8 boxes, that leads to a much higher failure rate. Also, there's a non-trivial overhead in starting one of these trial jobs, so we can't just throw more boxes at the problem to a degree. So this is a screenshot from my local MacBook Pro. I didn't get a chance I wanted to take a video of the tests running on Linux, because it's pretty cool to see all 16 emulators running tests at the same time, but I ran out of time for that. So, going through all of these tests and through this commit pipeline, there were still some cases where historically there was human intervention involved in the release process. One example was the localization team. Feature developers would check in code, send off their strings to the translators to be translated, they would come back, and then before we released a build, the localization team would look through the app and make sure that everything looked correct in all the different languages that we support. There was definitely not time to do this process in 3 hours, so we had to figure out how we could automate more of what they were doing. We sat down with the localization team and took a look through all of the bugs that they had filed for the flagship app over the past year. And we broke them into categories of different ways that we could catch these bugs without human intervention. We found that by far the biggest category of bugs was hard-coded strings or improperly formatted or concatenated strings checked into the code base. On the Android side, we had a lot of lint checks that we could turn on that would catch most of these things by default, and we wrote similar checks for iOS. And that cut down the biggest category of bugs that the localization team saw. The other big category was just strings that would get cut off or wrap improperly or not fit in more verbose languages. And our layout tests were able to catch most of those as well. They were also able to catch any right to left layout bugs, which is something that developers would often miss when they were doing their manual testing. The one category that we have not yet come up with a way to test automatically is the semantic correctness of translations. So sometimes a translator will receive a string, make a translation, but when they see it in context in the app, they realize a different phrasing would have made more sense. Right now, the translators are still periodically doing checks to validate that, and because this process is inherently human, but we're still looking into ways to help make that faster and easier for them. So once we've gone through all of this testing, how do we actually get the code out? So every 3 hours, our internal group of alpha testers gets a new build. And this is mostly members of the flagship team and people that want to be seeing the absolute latest code as soon as their developers check it in. Most of the rest of the company is probably a lot more like our typical users, where they don't want a new build every 3 hours. They don't want to be constantly downloading updates. Once a week is good enough for them. So every week we give the rest of the company a new beta build, which is essentially our release candidate. They will test it for a week while that build is in review with Apple for iOS. And then after a week of beta, we'll promote that build to production. And on the Android side, we can take advantage of Google Play's staged rollout feature to make sure that we are not introducing huge crashes or issues. To talk a little bit more about how we actually do that, on the Android side, we take advantage of Google Play's alpha and beta channels, which has actually been really nice for employees, because we found that one of the most common use cases in dog fooding is employees will go home for the day, then think to go use the app. A lot of our employees do use the app during their workday for getting their work done, but a lot of them also will only use it once they go home. And if they can't upgrade off the corporate network, it's a lot harder for them to stay up to date. But with the Google Play channels, they can get updates from anywhere. The one hiccup we ran into is it was a little difficult for a lot of our employees to get set up, because they had to add their LinkedIn account to their device and become a tester and make sure they had the right account selected in Google Play. But once they got through that process, they were able to stay up to date with no effort. On the iOS side, TestFlight would have given us something similar, but we have more employees than TestFlight allows users at the moment. So what we ended up with was a custom enterprise distribution with the downside that employees do have to be on corporate Wi-Fi to upgrade. To make sure that people are actually using the beta builds and not just the production builds, if an employee logs into the production build, they will see a super annoying splash screen that will tell them they should be using the beta build and give them instructions on how to get set up with that. So even with all of this testing, we still want to have the most confidence that we aren't going to mess something up for our members. We take advantage of LinkedIn's A/B testing infrastructure, not only for A/B testing. So anytime a new feature is developed, all the code is put behind a feature flag so that code can be ramped dynamically to different sets of users. Often it will start with just the particular feature team. We'll ramp it to the team so that they can see the work in progress. Once it's more polished, it will ramp to the entire flagship team and then onto the rest of the company. And once it's ready for production, we can ramp gradually to different sets of production users to make sure that there are no issues that we didn't catch in testing. This also lets us do some dynamic configuration for things that we're maybe not sure what the right value is for how often we should fetch updates while you're using the app. We can release this to production and experiment and see with tweaking what the right value is without having to release a new build. And as a last resort, if we end up releasing something that doesn't work and a bug that made it through all of our testing, we can often use this testing infrastructure to use it as kind of a kill switch for the bad code to make sure that we can stop users' devices from crashing without releasing a new version of the app. So as I said, we released the first version of Voyager back at the end of November. We spent December kind of getting on our feet with rewriting an entire code base and fixing any major issues that popped up. So essentially since January, we've been doing this 3x3 workflow. It's actually been very positive so far. On the Android side especially, where The iteration speed is much quicker, and a lot of our tooling is much more reliable. We found that that mindset of needing to get code in before the release has mostly gone away. On the iOS side, we're still going through some growing pains, especially with tooling instability and testing infrastructure, but we're getting there. There's some areas where we just have not prioritized yet and still need to improve. The biggest one is probably automating our actual process of releasing. So getting alpha and beta builds out to employees is automated, but uploading the actual production app is still a manual task for someone every week. The especially painful part is getting release notes, because we need to contact all of the different product managers and get release notes, send them off to the translators, and get those translations and input them when we upload the app. We want to get better at this so that we don't every week have general bug fixes and performance improvements, because we know that's not users' favorite thing to see, but we're still getting there. The other thing we want to look at is automated performance testing. We do have a performance framework that lets us look at the app running in production and sample data from real users to see if we've introduced any regressions, but we don't have any good way of catching that before we release. So that's something we'll be looking into soon as well. And on the iOS side, we want to continue making speed and stability improvements. We're hoping that as Swift continues to evolve, things will get faster and easier for us. And we're also looking into ways to do the same kind of multi-simulator testing that we do on Android, where we run several devices on a single machine to reduce our dependency on tooling stability. And finally, one of the most important things we want to do is bring this 3x3 framework to LinkedIn's other apps. So far, this has all been for the flagship app, but much of the stuff we've built has been in libraries that can be reused by our other apps. So documenting and evangelizing what we've done to other apps is another big area we want to work on. So I think that's all I have, so any time for questions. And if you take a look at the slides later, I have a bunch of blog posts and presentations put out by other members of my team on some of the details of the things we've talked about in this presentation. So, thanks.
Any questions?
The question is about what performance testing we've done. So pre-release, we've done mainly manual performance testing on different screens using the stock tools provided by Apple and Google. We don't have much in the way of automation yet, as I mentioned, but we do have code in our production app that will sample, for example, the amount of time a network call takes for a particular endpoint and send that back to us so that we can measure for different users and different locales and different devices that we can see where our slow points are and optimize there. So the question is more details about how our layout testing works. It's not screenshot based. We primarily use on Android the checks that are built into Espresso for things like view is left of, is right of, no truncation, no multi-line buttons. We've written similar checks on iOS, and that's primarily what we use.
One more question.
The question was about the order of unit tests versus building artifacts. Take the diagram with a grain of salt. On the Android side, we use both the JVM unit tests and the Android instrumentation tests. And I'm not as familiar with the details on the iOS side, but I assume it's just the stock whatever unit testing provides. Cool.
Okay, thank you.